So yeah, let's get launched. There's quite a few people joining in. I'll just start by introducing myself. I'm Bob Chamberlain. I am representing UDOT as the project manager for this research. And I wanted first just to introduce the TAC. They were quite active and instrumental to the success of the research. And the two project champions are Glenn Blackwelder and Mark Taylor. And also serving on the TAC were Travis Evans, Stephanie Tomlin, Trevor Egan, Chris Siavrakis, and Rudy Zamora. So thank you to all those people for serving on the TAC. The principal investigator for the project was Avenues Consulting, and David Bassett was really the point person for that. And without further delay, I'll just hand it over to him.
Thanks, Bob. And thanks for everybody who is joining and interested in learning a little bit more about the research that we did. As Bob mentioned, this is the research we did to develop a concept of operations for a mobile application that could interface with the central traffic system. We, Avenue Consultants, we were the principal investigators. I did lead the effort with some support from Shauna Burbridge, as well as Sean Larson, Nazat Azra, and Camille Hunt. We actually had a really great TAC. I want to give a shout out to them. They were really involved. They had a lot of good feedback. They were, it's one, literally one of the best TACs that I've worked with. And it seemed like everybody was really invested in getting the information, solving problems, and coming up with some feedback. So again, thank you to the TAC, and especially to Glenn Blackwelder and Mark Taylor, who definitely co-championed this and made this a lot smoother and whatnot. Today we will be reviewing our research, what we did, what our findings were, stuff like that. There is obviously our, as shown here, is the overview of our presentation. We'll talk about our, give a little bit of an introduction to the research. We'll go through some of the literature review stuff, what we did to develop, create a development plan, our data collection process, how we evaluated the data. We will then go through the actual findings of the concept of operations, wrapping up with our risk assessment and some final conclusions. So from an introduction standpoint, we are trying to figure out a way to use technology that's already out there for non-motorized users. That's a very important, because as part of the discussions, we initially started with pedestrians, AADT, but we found that this app could be very useful for also bicyclists and other modes, other non-vehicle modes. And one of the reasons why they wanted it is because current PED infrastructure is really expensive. It's hard to maintain, things break down. For instance, where the Bangalore project, it's currently under construction. I thought this was interesting. Driving through this morning, the new interchange at 104th and Bangalore, one of the headlights is stuck on green, which obviously is a safety issue and whatnot. And I'm assuming they're going to fix it since it's still got cones and everything like that. But those PED heads, they're expensive. The PED buttons, they're expensive. They're hard to maintain. The audible ones for ADA are even more expensive, and they have issues all over. If you've ever used one, you know that sometimes the voices are garbled, all that type of stuff. So we wanted to leverage the cell phone, where we have, Utah has 96% of all their signals are connected to the central system, and currently 85, and it's obviously growing. 85% of all adults have a smartphone. We wanted to make this, more of a technology-based rather than a hardware-based solution, and we wanted to integrate the process, the FHI process of IT development, ITS development, stuff like that. we also wanted to make sure we understood the risks and some of the challenges that we're going to do as part of the concept of operations. Two major tasks that we had was to do a little bit of a feasibility and concept exploration. Mark Taylor and Glenn Blackworth have both done quite a bit previous to this, so there was kind of a wrap up, and then develop a concept of operations. And we'll go into a little bit more of what a concept of operations actually is later on in the presentation. Our objectives was to minimize the risks and overrun costs, and to create a clear plan of how this application could be developed in the future, what it would take, and all that type of stuff. And some of the benefits of the research was, it's practical to create a concept of operations. From a financial standpoint, it's usually a fairly inexpensive step in the process, and it kind of helps you make that go, no-go type of decision. It also advances our understanding of what's needed, what's doing it as part of that research side of things. And then it's a great thing for the UDOT area of collaboration. So to do this project, we first needed to start with a literature review. Then we needed to create how we were going to develop the CONOPS, or the concept of operations. So that's not developing it itself, but we needed to come up with our methods and assumptions. Like most research projects, you need to come up with that, how you're collecting the data, how you're going to get people involved, all that type of stuff. Then, of course, to create a detailed concept of operations that could then be reviewed, and then talk about, of course, risks and opportunities, and then the final presentation, and that was our scope for this research project. So as part of the scope does leave out, app development was not part of this scope. Scope was the app development is future steps. This was to create a concept of operations. Literature review, there's three things we made specifically focused on. What is a CONOPS? That was a big issue for our TAC. A lot of you guys are not necessarily app developers or software developers, or even product developers. So a concept of operation was definitely a newer concept, a newer term. So we wanted to make sure that that was clear. Then we wanted to go through and detail, how concept of operations are organized in the DOT level, at the ITS level, and whatnot, and come up with how we wanted to organize this concept of operations for this product. And then, of course, we definitely wanted to review existing systems that might be out there that may do what we're looking at doing, and what the strong points and the weak points are of those. So from a concept of operations, this is the high level. It's a high level definition. It's not to get into the weeds. It's not the specifications. It's a high level. It's trying to define the who, the how, the what, the why, the where of those things. As the graphic shows, that's all fed into the concept of operations. It's a starting point, and it's a living document, but it's also a roadmap. Is another term heavily used to go back to as you're developing specifications, as you're developing an app or developing the product itself. You can go back to the concept of operations. Says, ooh, did we do that right? Are we really hitting the key? So it can also be used as, for the traffic engineers out there, as measures of effectiveness for the actual app development itself. And that goes into that system validation plan. Through a lot of different documents we looked through, we did define that this is the most typical as well as most universal organization for the literature review. Starts with a scope. You got to talk about some reference documents, user-oriented operational descriptions, some operational needs, the system overview, support, and then a lot of the things boil down to, from an application standpoint, the operational scenarios. Existing systems. We found 4 out there, all in various levels of completion and functionality. There was the maps, there was PedPal, the iResearch was doing Crosswatch, and Kimberly and Horton was working with kits. Do that. The good thing is a lot of these gave us some really good functionality for some scenarios. The biggest finding is none of these almost all of these required additional equipment at the signal. So it was the phone really talking to Bluetooth at a local situation rather than a central system. Kits was the one exception to that. It does connect to a central system, but it really was more for performance measures and malfunction alerts rather than an actual application that a pedestrian could use. So there were some limitations to what they could do and what. So to develop, sorry, was there a question? So to develop this concept of operations, we had to devise a plan. We had to develop the key steps in how we're going to do it, and more specifically, the stakeholders that were going to be used and when they were going to be involved in the development of the plan, as well as that. Stakeholders are actually a key component to all concept of operations, because it's the who, right? It's important to understand how the stakeholders play a part in not only developing the concept of operations, but also how they're going to test the app, how they're going to use the app, how all those type of things. So stakeholders was definitely a huge portion of it. Also for us, the definition of stakeholders was, who are we going to gather data from? So our key steps that we in our plan, this was went through back and forth with the members of the TAC to develop the plan. We got it reviewed, we got it approved. First thing is we needed to do a core steering committee. We decided that the primary committee was going to be the TAC and all the members on that. We then identified stakeholders and group participations. We decided to hold stakeholder meetings. We actually ended up breaking those into 3 different groups to make the meeting size a little bit smaller, a little bit more manageable. We then needed to prioritize. We decided we needed to prioritize those results and filter them, and then hold some final stakeholder meetings where we had that feedback loop. So we said, okay, this is what we found from all the different groups. This is kind of what we're looking at. We've met with the feedback loop and got additional information, as well as allowing them to ask questions and stuff like that. We finally met as a steering committee on the final, some of those final decisions and whatnot and organization. And then we, obviously, the biggest thing was to finalize the actual written document, which was the concept of operations. Key stakeholders is what was developed. And this actually, it was good. It was fun to work on. But as I said, we divided it into 3 different groups. We decided the customers, Ivana, Travis, Trevor, Derek, Michael, and Stephanie were great. They kept their focus on how can we use data, how can we use this type of stuff. So they were the customers. And customers is a different thing than operator. Operator would be the person who is actually operating the phone. The customer is who is the app data for, who is going to have to manage those things. Angelo, Heidi, and Trevor all were great assets in discussing how a user would look at this app, how the user would want to use the app, how the user would interface with the app, and whatnot. So especially when it comes to bike, safety and ADA and whatnot. And then of course managers, specifically DTS and AG's office. Those were 2 critical ones. As this is an application that we were looking at developing, DTS is obviously a critical manager, as well as the AG's office for privacy legalities, specifically tied to ADA and user privacy. We also involved Shane and Tom with Intellite, and then added Hamashui, who was one of their coders. Intellite's actually now Q-free. So they've actually changed their name since this presentation was originally given. And then Derek from DTS was manager. However, since then, Derek actually has left DTS. So as this moves forward, as a stakeholder, his position would need to be replaced. Our stakeholder meetings, as I said, we broke them into 3 different meetings. Those 3 classifications, we got them together. It was a virtual meeting, which still actually went very well. I was really impressed with the feedback and the interaction, even being a video conference rather than in person. But we wanted to set up those initial meetings, which we did. We gathered a lot of information, and then we had our follow-up meetings after we kind of fine-tuned got some of the priorities and stuff like that. Here are the dates we did. Managers were a little harder to get together as a one. So what we ended up doing is meeting with them almost individually. Not to mention that, Intolite had very specifics, the AG's office had very specifics, and then DTS very specific. So we found that actually, at least for the initial one, for the initial meetings, it was easier to just kind of break those out and meet with them individually. Follow-up meetings were then held. We actually had a couple of them for customers and operations because, again, it was important for us to make sure that our stakeholders got that feedback time, that circular information format. So we actually had a few of them so that we could make sure we included everybody. Some of the highlights from these meetings were from the customers, again, data need. A lot of discussion about connected vehicles and autonomous vehicles, how it could be interacted, stuff like that. Connection with navigation. Navigation was a big one where we talked a lot about how we could maybe plan things out and go what's the pedestrians or bikes next step. For instance, features like the next step and whatnot. Misuse was a huge one. It actually followed the conservation or the concept of operations kind of all the way through. That was a big concern for the UDOT stakeholders is what happens when somebody tries to misuse it and whatnot. From the operator standpoint, some of the great ones like simple and big. Big buttons and simple. That was a huge one. Classify different users, and then some of the data needs for volume, special needs, and again, as part of the concept of operation, we did actually implement the concept of we need to have focus groups in the later phases of the development. Managers, data restrictions was a big one for that. We learned and defined some of the issues with data privacy. Is basically what is private data versus what is not private data, and how can we anonymize some of those things when that was discussed with both DTS as well as the AG's office. We ended up saying that working with Intolite, we found out that they were developing they were finalizing development of a new central system called Kinetics, which we're currently using. UDOT was actually, I think they're migrating over. They're doing a test case of Kinetics now to replace the current version of MaxTime. And we found out they were already developing ways to have external applications interface with the central system and whatnot. And we did talk with as well as how we could adjust wait times and all this type of stuff and get the feedback loops for those things. So there was a lot of system and feasibility things discussed as well in the managers group. So the next thing is we gathered all that data. We had, I don't remember exactly off the top of my head, but 50, 60 type data points that we went through. And we're like, okay, how are we going to prioritize this? How are we going to filter this? How are we going to score this? So we tried to make it very simple. We created a Google Doc, listed every single item, and then all of our stakeholders, we sent it out for them to fill out individually and independent from each other. And score basically each one. They got a score from 1 to 5. 5 was, I love it, I have to have it, this is so important to make this thing work. Again, 4 would be, I like it, I want it, all the way down to, I don't like this, filter it out, just it's garbage type thing. We took those scores and then averaged them. We did a straight average, and then we assigned those scores to a phase. For instance, phase 1 would have been 4.5 and above. Phase 2 would have been 3.5 to 4.4, and so on and so forth, to try to keep those averages. So here, showing in this slide are some of the ones that were top ranked. Everybody wanted them. We want to make the signals more accessible to pets. That's a huge need. It needs to be applied system wide. And we want to target the target of that system wide was the fiber connected to minimize delay and latency issues. One of the aims needed to be for disabilities and whatnot. And again, central system, and they wanted to make sure it had compatibility with Android, iPhone, and the Google platforms type stuff. And once we had these, we then reviewed them, and there were some that kind of fell out. For instance, there were some that fell into phase 2 that actually were critical for functionality purposes of the app. So we kind of we did some manual bump ups and changes. We met with UDOT, the TAC, and reviewed those manual shifts to make sure everybody agreed. Made some additional changes from that, and then we basically used that scoring mechanism to make sure, or to apply everything to the CONOPS itself. So the next step was to write up the concept of operations. And so concept of operations, the scope, the idea was to just, it justifies the need of the project. That's one thing the scope had to do, and just identify some target locations and target populations as well, which of course, in this case, was using the central system. We did no need, the app could not require the additional equipment at the signal. That's just extra cost that we didn't want to do. And this we did determine that phase 1, the target audience would be pedestrians and pedestrians with disabilities, with phase 2 including some other alternate modes such as bikes and others. So that's kind of the scope of this project, of the concept of operation of this app. Next thing was to document all the reference documents. Again, some of these are legal from the AG's office. Some of them are coding restrictions, security measures, and stuff from DTS. So, for instance, the HIPAA rules for collecting personal data. That was a huge one that we had to identify. There was some software development life cycle from DTS that we needed to include, and of course standards like NTCP/IP, JavaScript, JSON, which are coding languages that DTS really wanted to kind of include, as these are critical to the development of the app, and of course ADA compliance and all that type of stuff. So we created a list of reference documents, how you could find them, where they were attached, and how they were generally to be used. Concept of operation documents the user-oriented operations. So this is really talking about major reports. It's a higher level discussion. You get into some of the scenarios later on in the concept of operations. So here, these things were kind of like the large buttons, confirm location and direction, haptic. We wanted vibrations and or audio feedback, and then ADA versus non-ADA modes type stuff. And then again, phase 2, including some of those navigation features and stuff like that. So that's kind of those are the types of things that are held into this section. Again, one of the user operations, one of the important things for this section was to define user groups. So we created, for all intents and purposes, kind of like a hierarchy or a flow chart of who needs to be that. So, because this is again critical for UDOT, is because they have to maintain certain staff to support this. So we determined there were 3 major managers, one in traffic and safety, one in the signal operations group, and then one in DTS. Those would then help manage and align focuses. For us, the traffic safety manager would communicate with communications, the UDOT communications, and AG's office. Communications for rollout, improvements, updates, AG's office for privacy and ADA requirements. They would also manage the focus groups as somebody at UDOT would be selected as a focus group leader, and they would help manage that type of stuff. Whereas the signals operations would interface a lot with DTS, because they would manage the back end side of things, if that makes sense. And so we had to create that that team and how this application would be supported both in development as well as in implementation. So operational needs, you know, these are more a little bit higher level type stuff. And a lot of people think operational needs, they think of jumping into the scenarios, which again is kind of one of the differences between concept of operations. So, you know, what are some of these high level things that it needs to do? It needs to provide additional safety. It needs to allow for crossing time to be extended. You know, if somebody doesn't walk in that 3.5 miles an hour, you know, if they can't cross that, whether they're in a walker or a wheelchair, or just older and just walking slower, or younger and just can't walk, it doesn't have a long stride, it doesn't matter. There's a need for potentially some extended time to make it safe for them to cross. And then, of course, a huge aspect that was discussed a lot was just improving the overall experience at the intersections. As anytime you've ever been a pedestrian, you know that crossing, it's not a fun experience. You get sometimes good information, sometimes back. Your heads can have a countdown, but they may not. You may just get a flashing hand and whatnot, and you really have no idea. But also, I know everybody here's come to a crosswalk at one time and push the button, and they have no idea. Did it work? Did it not? That stuff. So that feedback was an important discussion point in this app and what it needs to do, as well as, again, what kind of quantitative data can we collect legally and privately. Some of the other operational needs that we're talking about, specifically for phase one: request more time, haptic, confirm map features on GPS. That was a critical one. Is they wanted a map to say, okay, I'm here. That is, again, ability to bar misuse. Some of the things in phase two really gets into the data collection, pedestrian versus cyclists, being able to track ability safety, and then real-time countdowns. So basically, in a sense, what's the real information coming from the signals ops? So not necessarily just the signal head or pedestrian signal head, but also like here's how long it's going to be before you can walk green, and here's actually the time that it goes until everything turns red, type things. System overview. So this is a very important part from a logistics standpoint that has to be in a concept of operations. Is we need to discuss the actual system itself. So we put together this diagram. You have obviously your system initialized by the user, pushes a button. They're monitoring this. They open up the app and then they monitor the system. They say, oh, I'm here. Yes, that's me. I want this. I want to cross here. As they're coming down, they choose the crossing direction, saying I want to cross this direction. That goes to the central system. Central system sends information back to the user saying it's been received. Thank you. Here's when it's going to turn, and then of course it sends it to the actual signal itself and meaning the signal controller, and says somebody's out here, they want to cross here on this phase and whatnot. So that's the overall system architecture for it. The additional information that is needed is like the server communication. So this is a more server communications, actually how all these messages come through and stuff like that. Or the idea was obviously to have an app. That's hence the title of the research, is to have an app, and that app is actually going to be talking to a standalone web-based server in a database. So that actually is important from a privacy standpoint. It helps us create some firewalls between personal data and the count data and stuff like that. So it allows us to easily anonymize the information that you're going to do it. So that information, that app information, is going to be that. Some of the other information that would be on there would be tied to the geolocated, where are you, that type of stuff. And the UDOT server will then feed back, the ETSPM server will feed back some information about what signals you are and that type of stuff. Then again, it'll also have a backup server. That is, so if something fails, if the UDOT server fails, it'll immediately transfer to the backup data. So the service will pretty much won't be able to go down. And then obviously figure out why the server went back up. Main one gets back up, switches back to the main server. But we wanted that redundancy for just operations. The important feature is that the apps will actually use the broadband data service, talk via the internet or the cloud, and then so there's no additional hardwiring or anything like that. And then of course the server will talk to the interim data storage, which is actually right now the plan is to be the ATS-PM server system, which will collect ped counts, that type of stuff in it. And then that's obviously also linked to the central system kinetics. So you're going to have some hardwired stuff between signals and the central system. And then obviously the UDOT cloud server versus that they'll be Wi-Fi and that type of stuff. Organizational interfaces. We created this figure more to help lay out who's doing what and kind of how the communication is. For instance, user needs, these are the non-operational users. The idea for that user group is to improve safety. The application providers provides the functionality. So this is the app developer, the operators of the back-end type systems. Communication systems, they provide the communication between that mobile app, which is Wi-Fi, mobile data, and then the fiber network to the signals themselves. The central system, it provides the requests to the users and feedback, provides the functionality to request by the users, but also feedback to the users, so it's bi-directional. And then the cloud base is where we're good. So those are just some pretty typical standard type of communication methods, organizational interfaces, how they interface and all that type of stuff, as well as the server, how communications go through the system. So that was part of the system overview that was developed. And again, kind of going back to that, hierarchy, the management structure, stuff like that, we needed to create we needed to document what was needed to support an application of this type. Facilities, we needed in the TOC, you have the TOC, you have servers there, you have cloud storage, and of course the TOC also houses the central system, whatnot. Equipment, connected controllers. Obviously, if the controller is not connected to the central system, it won't be able to work. Type stuff, just pretty much like any of our sister systems, so you can't just talk to it. Hardware, you're going to have to deal with data storage. So there is going to be a data storage issue or concern, cost associated with that, management, upkeep. And then the user cell phone is the other type of hardware. Software, kinetics are similar, and then NTCP, networking, and all the switches and stuff like that, which again are already built into the connected system that UDOT uses. Personnel, you need some decision makers. There is going to be maintenance, just development upkeep, so like changes to the app, things for that, updates to the cloud servers, updates to the data management structure, and a big one is outreach, because if UDOT is developing this, it's not going to just, everybody's going to know about it. You're going to have to do outreach. You're going to have to get feedback. So there's going to have to be some outreach personnel to help support this. You're going to need legal support from the AG's office, both for the PII as well as ADA. Operational, you're going to have to, procedures, you're going to have to do that. And then focus groups, and then of course phasing. We need to make sure that the phasings is followed and stuff like that. So this gets into some of the more what most people think about when you talk about apps. These are the scenarios, but the scenarios are not just use scenarios. We also have fail scenarios and misuse scenarios that we needed to do it. So the primary scenario that was basically being discussed is somebody pulls up their app, they open up the so they're looking at their phone, they say, oh, they're with the built-in GPS locator, says, oh, I'm here, that's the signal I'm at. and I want to cross northbound. And they click that. That information is then sent to the cloud server. The cloud server says, oh, they want that direction. However, that's actually phase 8 at this signal and whatnot. So it basically converts the information from the user-based information to the central system needs, and converts that, sends that signal to the central system. System says, okay, I got your signal, sends a handshake back, says, I got your request. So they know, oh, they did hit my request. It wasn't just a faulty button, but they did get my request, as well as information, feedback information about when the light approximately will turn green. Type information. This also sends that information, the detector request information, to the signal controller, gets it in the queue, so that as the phase comes up, it'll actually make the changes to the ped heads and information. All the while, again, giving feedback back to the user for that. That's our primary scenario. Fail scenarios is, just for instance, we had to come up with some mitigation things for what happens when the cell phone app doesn't, when the cell phone data doesn't connect. So, for instance, you guys may have had an app where you pull up, it's like, oh, it's not working, it's not working, it's not working. But it may be you don't have connection to the system. For instance, your data's down, or you ran out of data, or you have no signal. That's not really an error up for the app, but when you open the app, as many of you guys have probably used other apps, it pops up and says, hey, cannot access your data. Maybe try connecting to Wi-Fi or something like that, depending on what it is. So you want to have that feedback as part of the app, so that they know the app isn't just not working. It's the fact that it has a communication fail. Similar type things would not just be the cell phone communication failing, but the actual server, the servers themselves working, or the central system is down. We need to have scenarios in which it gives that feedback to the user that the system is down and this is why. So system's down, try back later. Or system's down, in this case, system's down, please use ped button. Whatnot. Misuse scenarios is, again, another big one that is a little bit, we talked about a lot, is, do you really want the pedestrian to push the button and call a signal when they are miles and miles away? Somebody could really screw up things and just be adding, I can see some teenager, right? It's like getting here, I was like, oh, one of the ways to mitigate that is put a geofence. So basically say, from a location device, if you're not within this proximity of the signal, you can't request anything from that signal, type stuff. The other one is non-motorized transportation. This was brought up in our stakeholder meetings. It's like, what if somebody wants to extend their green time? So they pull out their app and their phone, they're driving, and they request it to extend the green time for them because they want a little extra time in their driving. A few ways we could do that is, again, kind of geofence that they're on the road versus that, but also speed tracking. If you're traveling too fast, a ped can only travel so fast, a bike can only travel so fast. But if you are traveling too fast, do that. So we came up with these misuse scenarios and put in mitigation things of how we could eliminate those. And again, we broke those into phase 1, phase 2, and we actually had an additional features that didn't fall into phase 1 or 2, which are really good features, but they basically need to be reevaluated after you have a functional app and after you get through phase 2 or into phase 2 development. You can go like somehow interact it with the click and fix UDOT. So basically, hey, the ped signal's not working, or this crosswalk I can't see it anymore, or just the anything that they can think of as a pedestrian and not just as a motorized user. So those are the main concepts, are parts of the concept of operations. So we have an official document. You can read it. I want to say it's like 15 pages long. That goes into a lot of the details that we talked about, and even more details of breaking out into phase and all that type of stuff. That was, of course, just a highlight of what was in it. The next step was to do a risk assessment. This was actually really fun. We got a bunch of people together. We used a tool called Mural, and basically through all sorts of risks that could be up. We created this forum online. This was a video conference. We created this forum in Mural and just basically put sticky notes and said, okay, I have this. Then we started organizing it and got it into, we have, where do we have risk? Operation maintenance. We have funding. What issues do we have? The central system, data storage, legal, application. Some of the cool ones that came out of here were, of course, funding. Funding is going to be a big one. But some of the issues of UDOT does not own all the connected signals. So local agencies, do they even want to have this operation, and can their local rules and regulations do it? So one of those risks is that legal agencies have their own issues. Mitigation, again, we need to define what the success looks like. We need to include some of these local agencies in the process of stuff like that. Market penetration was another big one, because if you don't have enough people using the app, then ultimately what good is it going to do? And so one of the things that need to be decided as part of the specifications is what market penetration do you need to have and whatnot. Leadership buy-in was a big one. It's actually one of the ones that I know Mark is currently working on. Mark and Glenn are currently working on as a way to get leadership buy-in for this. And federal approvals. There's a big push right now from the federal FHWA to be compliant with a specific type of solution. And we're going to have to work with the FHWA group and with UDOT leadership to show that this meets the actual requirements and needs of the user and should be approved for those type of things, type stuff. And again, legal, specifically with the ADA requirements, but also the data privacy type stuff, making sure things are anonymized, stuff like that. And we covered a lot of those with DTS and the AG's office. One of the great things that from this says, there are no roadblocks. That was a great feeling when we finally finalized all that stuff and I met with DTS and met with the AG's office, and then I go, yeah, I mean, we're going to have to do certain things here, and we can get around, not get around. We can take this path and take that path, but ultimately, where we are to where we want to be, there are no major roadblocks from a feasibility standpoint. So that was great. We do need to manage sensitive data properly. We do need to follow, data storage requirements and system operations as laid out by some of DTS's implementation guidelines. But ultimately, those risks are that. So some of the results: seek funding through UDOT and then maybe through some grant programs. Involve DTS at every level, including the start, which is budget and estimation process. That was a big takeaway from risk management for this, because it is a mobile app. Involve DTS all along the way. Then lobby for the leadership, local agencies, and FHWA. Be active in those to show those benefits. And again, coordinate. The other thing is to coordinate with AG's office every step of the way, as well as involve other outside entities, specifically having to do ADA, like the Development Disabled Council, the Schools with the Blind, and some of those. You get those users involved at a appropriate but earlier stage type stuff. So project milestones, we actually have completed it. The final report has been approved and it's been loaded to UDOT's library. And it was absolutely a fun project. It was very interesting to get different people's points of views on what a mobile app would look like, what it would do, how it would be used, what the issues are, type stuff. Again, want to thank the great TAC for being so supportive and so involved as well as all of the stakeholders that were involved. I know this it's a lot of time and effort on your guys' part, and you guys really made an effort to be available and to use everybody's time very efficiently and stuff like that. So with that, next steps are simply go forward to system requirements and high-level design, and that's going to require funding and as we talked about the leadership approvals and all that type of stuff. But next steps is just to move forward in the ITS development process, which is again develop system requirements, and those are the detailed ones. So it's very laid out, very specific. We want it to do this. It's going to be this color. It's going to be this size. It's going to be all that type of stuff. Lay it out as detailed as you can. Then get a developer on board to do a high-level designs and whatnot. So that's I guess that's our research in a 40-minute nutshell. I guess Robert, do we take questions? Anybody have any questions?
Yeah, thank you, David. That was a great summary of many months of hard work. Yeah, we have an hour set aside and 13 minutes left. So any questions from those in attendance? Fair game now. Yes, Nita.
Hi, thanks for this great work and also the great presentation. Much needed and valuable topic. So this is my first time actually I cross paths on this topic. So I haven't read the report yet. Maybe I can find that my answer on that one. Or maybe this comment may not be feasible, but I would just throw it out. So since one of the main objectives is making, one of the main objectives for this research is making it easier and safer and also more compatible for ADA users. Is it possible to install like a pet motion detectors on signalized intersection itself to give, for example, extra green time to the humans as long as they are in the intersection, plus some extra 3 to 4 seconds to assure that they finish like crossing and the crosswalk is clear? So I'm asking that because I was just thinking that would omit the middle process, which is the app here, to save, as you said, like some of the stuff you said, to save time, money, data storage, or prevent some of the misuse you presented in the presentation, or some of the other failure scenarios you discussed, like when the pet hasn't finished crossing yet, and also how do this work in the future with the EVs, like, because then there's even there's a need for extra time for those intersections or those mobile apps to send signal to the EVs when they're getting closer to that intersection. So maybe asking the question this way, that we know we have some problem with crossing time, regardless even of the user's condition, because I have problems sometimes. And so what are the pros and cons to approach to resolve this issue with app versus without app? Like, to just put that into intelligent signals intersection system itself. Have you looked into this or found successful literature on this?
So we did talk about that a little bit. The key, one of the key concepts of this this specific research was to figure out what it would take to do a mobile application. But we did actually have initial discussions in our earlier things about there are other ways to accomplish this. And everything comes with the pros and cons and stuff like that. And one of the key focuses of this was, how do we do it without additional equipment? How do we take our 1900, 2000 signals that are currently connected and make them work overnight and whatnot? So there are definitely some pros and cons to every type of situation, but this research did not go into the details of the pros and cons for each solution alternative. We were focused on what are the pros and cons of a mobile application. As for the CV, connected vehicles and stuff like that, there was actually a lot of discussion that we had from that. With the advancement of EVs and connected vehicles, and connected infrastructure, with the app in the future phases, we wanted to be able to talk directly to the cars, so that the the mobile app could actually indicate that a person is actually in the PED crosswalk and actually send that information directly to a car that may not be within its sensor locations and stuff like that, as well as sending the information from the infrastructure. So the central system sending information to vehicles approaching the intersection that a pedestrian is there. So that a pedestrian has requested time. So that pedestrian may be on the sidewalk, right? And so like he's requested time, so that will give like right turning vehicles and stuff like that, saying somebody's there. You know, so when the driver isn't paying attention necessarily, that a pedestrian is at the intersection as well, with connected vehicles and stuff like that. So we do want those features to be involved. Right now, the limitation is as much this connected vehicle systems as it is anything else. But we do want that to be and it is part of the future phases as documented in concept of operations. Did that answer your question?
Oh yeah, thank you. And also just a follow-up question. Do we have any number that how many users, potential users we will be having, like in state of Utah? Like, for example, you said that there are 2,000 signals intersections. So how many like ADA users or the people who are qualified to use this mobile app? Do you have any number for that community?
This research didn't look into that. I don't know if some of the other TAC members have a better understanding of that, but we did not specifically document that.
Okay, thank you.
I would note that Netta, to your comment, we wouldn't necessarily restrict this to users with disabilities. Anyone could use it. We wouldn't necessarily have to enable the extra time if we've got someone who's got a walking speed that's above 4 feet per second. But the app could still be useful.
And our research did document that, as Glenn was saying, it did document that to make this app as useful as possible is make sure it's usable for all pedestrians, both with disabilities as well without. It would include better market share, it would include better use, and it would just make our system overall better by including both all pedestrian users. And then again, in future phases, all non-motorized vehicles or users, sorry.
Thank you.
I think one more thing to add, Netta, to your initial comment about using detection to detect whether pedestrians are in the crosswalk. That's definitely something that I think we're continuing to look at. You know, Mark may be able to speak more to that than I can, but that does involve extra equipment, extra configuration time, and would tend to be a lot more resource intensive than the app approach.
Yeah, like make more sense. But when I was talking about this, I was thinking about like the ADA community. But when it's for all users, probably when we have millions of people using those intersections, that makes sense to go with the. Sometimes, I mean, not either or, but it makes sense to have some even extra equipment on intersections. Because for all the people, rather than asking like everyone to use the app to buy themselves some extra time. Do you know what I mean?
Yeah, I don't think that the app's going to resolve all the pedestrian issues, but it is in terms of the amount of money that we're spending, it's a pretty big bang for the buck.
Yeah, definitely. Yeah, thank you.
Any other questions? I did want to add, I've reached out to Rudy Zamora at DTS, and they are still putting together the estimate for app development, just so you are aware of that. And I don't know, Glenn, are you at liberty to talk about any of the progress you've made in terms of moving this to the next stage?
All I can say, I think, is that we've got agreement in principle between traffic and safety and the traffic management division that this is something we both want to move forward with, and that we were both willing to put money into. I think we're still working on the details of what that next step looks like.
Great, thank you. One thing I neglected to mention at the outset is that if anybody would like a PDH, Professional Development Hour certification as part of this, please email me and we'll get that out to you. You can get my email in the meeting invitation. Any final questions from the crowd? Quite a few people in attendance. Okay. Well, hearing none, thanks again, everyone, for attending. And David, again, great piece of work, and hope we can move this forward.
That'd be great. Appreciate it. Thank you, everybody, for your time.
Okay. Thanks a lot, everyone.